Hello, calculus fans. Let's say we have these two lines, L1 and L2, and we're given parametric equations of these lines. The second line has an unknown value in it, some parameter. And let's suppose that we're given that L1 and L2 intersect. Let's find alpha, and we're going to find the intersection point. Now let's notice that these two lines have different parameter variables. Because they're separate lines, we really can't use the same parameter for both lines. It wouldn't make any sense to do that. So we can set the x values equal to each other, and the same for the y values, and the z values. Now the y values have an unknown quantity, this alpha. So let's ignore that for now. Let's just set the x values and z values equal to each other. So here's the system of equations that we get by setting the x values equal to each other and the y values equal to each other. So if we substitute s equals negative 3 plus 5t into the first equation, we'll get 2 plus 3t equals 4 plus 2 times the quantity negative 3 plus 5t. Okay, I won't bore you with all the algebra. That gives us t equals 4/7. So we're going to plug s equals negative 1/7 into the equation that I've circled here. That's going to give us the value of s. Then we plug the values of s and t into the y values and set them equal. Remember that the x, y, and z values have to all be the same at the point where t equals 4/7 and s equals negative 1/7. These lines are supposed to intersect. So we plug those values in and set them equal. And then what we'll get is 1 plus 2 times 4/7 is equal to alpha plus 3 times negative 1/7. So alpha is equal to 18/7. Now let's find the intersection point. We'll plug in t equals 4/7 into the parametric equations of the first line. If we do that, then we get these values of x, y, and z. So that tells us that the intersection point is 26/7, 15/7, negative 1/7. Now let's do a quick check just to verify that we really have the right thing. The way we can do that is to plug in s equals negative 1/7 and alpha equals 18/7 into the parametric equations of the second line. What we're hoping is that if we do that, we'll end up with the same point. And if we do, we get x equals 26/7, y equals 15/7, and z equals negative 1/7. And that confirms that our intersection point is the right thing. Now this is an example of intersecting lines, but it's actually possible for two lines in R3 to never intersect. Those are called skew lines. We'll run into those a little bit later on. Okay, that's all for now.